Hello and welcome to Tribe Topper. In this video session, you are going to learn about potential difference. We know whenever something has to be moved from one place to another, some work has to be done. So same way here, if we say we have a charge Q, this is a small charge Q at the position A, and it has to be moved to a position B, then some work will be done. And this work done per unit charge is known as the potential difference. So how can we define potential difference? We'll say the potential difference V between 2 points is the work done per unit charge to move a point charge from one point to the other. So mathematically we can write that potential difference V is equal to W over Q. W is the work done over Q, or we can also say it's the energy spent per moving a unit charge. The SI unit for potential difference is volt, and 1 volt would be equal to, we have to substitute everything as 1, so we'll say it's 1 joule work done to move a charge of 1 coulomb. The potential difference is 1 volt. I would also like to tell one very important thing about potential difference here, that I would also define it as an essential condition for the flow of current. It is an essential condition for the flow of current. Now, why do I say that? So, let's have a look at a conductor. So, let's say this is a conductor AB. Now, this is a metallic conductor and it has free electrons which are moving around in random zigzag motion when there is nothing connected to it. But the moment we connect it to a battery, what happens? By connecting it to a battery, we created a potential difference that is negative on one side and positive on the other side. So we created a difference in the potentials of the terminals. Difference in the potentials of the terminals A and B. Now, whenever there is a difference in the level of something, like you have water always falls from higher level to lower level. So here we have created a difference in the potentials. So this side which is negative has excess of electrons, and the other side A which is positive is deficit of electrons. So we created a difference in the potential or difference in the concentration of electrons. So naturally they will start moving from the higher concentration side to the lower. Just as the law of nature, everything flows from a higher level to a lower level. And this current continues to flow as long as there is a difference in the potentials. Once both the terminals A and B reach the same potential, the current stops flowing. So when the potential difference reaches 0, that means both the terminals A and B reach the same potential, the current stops flowing because now there is no reason for the electrons to flow. Another important thing we need to know here about is electron volt. This is the unit of electric energy here. Now see how. We say, what is electron volt? It is the work done when a charge equal to 1 electron charge is taken across a potential difference of 1 volt. We actually get this definition or this expression from the definition of potential difference, which is V is W over Q. Therefore, what is W? That is Q times V. So, work done when, if the work done we are talking about is to move a charge Q equal to 1 electron. So, we are moving 1 electron when potential difference of 1 volt is applied. So when a potential difference of 1 volt is applied and 1 electron moves, then work done is equal to QV. So that is 1 EV. So this is known as electron volt, and this is because the unit of work or energy, so this must be related to joules as well. So let's see how much is this electron volt in joules. So 1 electron volt in joules would be, the value of 1 electron is 1.6 times 10 to the power negative 19 coulomb into 1 volt, which means this is 1.6 times 10 to the power negative 19 coulomb volt, and coulomb volt is what? Joules. So this is 1.6 times 10 to the power negative 19 joules. So whenever you have to convert electron volt, 1, 2, 3, 4, any number of electron volts into joules, just multiply that number with 1.6 times 10 to the power negative 19 joules. So here we have a question which says that determine the speed of a proton m whose mass is a proton whose mass is 1.67 times 10 to the power negative 27 kilograms that is accelerated from rest by a potential difference of 5 times 10 to the power 3 volt. So how do we approach this question? First of all, write the given equation. The mass of the proton is given to us 1.67 times 10 to the power negative 27. In case the charge is needed, that would be plus 1.6 into 10 raised power negative 19 coulomb, because it's same as that of electron, just with the opposite sign. It is accelerated from rest, so initial speed was 0, and it is accelerated by a potential difference of 5.0 times 10 to the power 3 volt. We have to determine the speed of this proton, how much it acquires when it was initially starting from 0. Okay, so first of all, let's find out how much work is done in accelerating this proton by the electrical force. So work done by the electric force, that means by this accelerating potential difference, is equal to QV. We just learned that. So therefore, work done is equal to Q. The charge we are talking about is a proton. So 1.6 times 10 to the power negative 19 times V. How many volts we have applied? 5 times 10 to the power 3 volt. So this gives me a value of 8 times 10 to the power negative 16 joules. Now this work goes into what? In accelerating the charge. So this work done goes as, or appears as, increase in the kinetic energy of the proton, right? So this work appears as the kinetic energy of the proton. So let's equate this work done as half mv square, and we need to find v. Therefore v would be equal to 2 times work done upon mass, and taking the square root of that. So we'll just plug in the values now. That means v is equal to square root of, I hope everyone understood that work done is half mv square, because work we are doing in accelerating the proton appears as the kinetic energy of the proton. So from here you get v is equal to square root of 2. This goes here, multiplies with w over m, and take the square root. Now plug in the values. 2 times w, 8 into 10 raised power negative 16, upon, we have the mass of the proton as 1.67 into 10 raised power negative 27. So this comes out to be 9.8 into 10 to the power 5 meters per second. So this is the speed gained by the proton. The second part of the question says, a proton with speed 4.4 times 10 to the power 6 meters per second enters a region of electric field directed in such a way that the proton is slowed down. Determine the potential difference required to slow the proton down to half its initial speed. So how much is going to be the change in kinetic energy when the proton slows down? So the change in kinetic energy will be, initially it would be higher, so we'll take half mv1 square minus half mv2 square. Otherwise we'll just get it as negative, because energy would be lost. So half times m is 1.67 times 10 to the power negative 27 common outside, times v1 square means 4.4 times 10 to the power 6 square, minus, when the speed is reduced to half its initial speed, so the final speed v2 is going to be 2.2 times 10 to the power 6 square. So solving this, we get the change in kinetic energy is 1.2 into 10 to the power minus 16 joules. Now this kinetic energy, change in kinetic energy, is brought about by what? A repelling potential difference this time. And how much is that potential difference, or that work? Basically in the previous part we did the work appears as kinetic energy. Here we'll say the change in kinetic energy appears as the work. So work is equal to delta KE. So we'll again equate this change in kinetic energy with QV. And 1.2 times 10 to the power negative 16 is equal to Q times V. But this is in joules, so we have to divide this energy because on the units should be same on both sides. So we'll divide this by 1.6 into 10 to the power minus 19. And this Q is E basically same as that of electron into volts. So therefore, how much is the voltage that we got? You solve this, you get 750 volt as the potential difference which is required to slow down the proton to half its initial speed. That's all for this video session. In the next video session, you are going to learn about power and the relationship between the power, current, and the potential difference. Thank you.